So having met the equilibrium constant, Kc, let's go through some example calculations. So let's get in to this and do question 1. So we've got a equilibrium there where we've got ethene and steam making ethanol. We've been told the moles of ethene and steam we've started with, the volume of the container, and how much ethanol is formed at equilibrium. So the best way to do this, I find, is to write the equation out and pop in the figures of the initial moles that you start with of your reactants and products. So I've done that. And then at equilibrium, we've been told we formed 0.0112 moles of ethanol. So that means that during a reaction, I have formed 0.0112 moles of ethanol. Therefore, I must have lost the same number of moles of both steam and ethene because it's a 1-to-1 reaction for all. So if I take 0.0112 moles from both ethene and steam, I get my equilibrium moles. I then need to convert into concentrations, but because it's 1 decimeter cubed, I get the same numbers. I just divide each one by 1. So we can now pop those numbers into Kc, as shown there. And if we do that, we get our Kc as being 0.301. We need to think about units though. Units are in moles per decimeter cubed for those concentrations. You can see that we can cancel those down, and therefore we will end up with moles to the minus 1 decimeters cubed. We can now move on to example 2. And there it is. All getting a gaseous reaction. So we could have used Kp, but the question is asking us to use Kc. So we've been told moles of carbon monoxide and moles of nitrogen monoxide in a 2.6 decimeter cube container, and we now have formed 0.132 moles of nitrogen. Find Kc. So again, we pop those initial moles underneath the reactants, and we haven't had any products formed initially, and at equilibrium 0.132 moles of nitrogen. Now here we have to be careful because for every one N2 molecule produced, we produce 2 CO2s. So we've gained 0.132 moles of nitrogen, which means we must have gained 2 times 0.132 moles of carbon dioxide, and that means we have lost 2 times 1.32 moles of both NO and CO. So those are our final figures, and we also now need to change those into concentrations by dividing each of those by 2.6 to give us our concentrations in moles per decimeters cubed. So we have those numbers now, and it's just a matter of popping those into Kc, which is shown there. So we pop those numbers in, and this is normally where the error occurs when we put them in the calculator, and we end up with a value of 914. So units, how are we going to work out our units? Well, as before, we're going to now have on the top moles cubed, and on the bottom moles per decimeter. So we're going to have on the top moles per decimeters cubed, and on the bottom moles per decimeters cubed to the power of 4. So we have the same units as before of moles to the minus 1 decimeters cubed. Question 3. Again, we have a gaseous reaction, but we're going to use Kc. We've been told Kc in this case, and how many moles of NO and O2 were present at equilibrium, and we need to find how many moles of NO2 were present at equilibrium. So again, it's a very similar procedure. Let's write Kc out. However, we can now substitute in what Kc is as being 45. And we need to convert those moles of both NO and O2 into concentrations by dividing them by 2.5. And we can pop those into our Kc expression. Rearrange it. And then take the square root to give us a concentration of NO2 as being 0.591 moles per decimeter cubed. They wanted to find out exactly how many moles we had, so we need to times that by 2.5 to find the moles because we've got concentration. And so our final answer is 1.478 moles. Before then, we now have a heterogeneous equilibrium. So we've been given Kc at 298 Kelvin, and we have how many moles of Br minus have been added to solid silver chloride, and we need to find the concentrations of Br minus and Cl minus at equilibrium. So let's look at our initial moles. Obviously, we don't need to worry about the two solids there. They will not be included in Kc. And at equilibrium, we can say that we have formed Y moles of Cl minus, and if that's the case, we must have formed 0.1 minus 1 moles of Br minus, because for every 1 Cl produced, we have lost a Br minus. So we now change those into concentration by dividing by the volume. They haven't given the volume, so we will just say the volume is V. So it's slightly more confusing than the previous examples, but they have given us Kc. So let's pop in our Kc like so, and we pop in the values of Cl minus and Br minus. You will see that the volumes cancel for both, and therefore we are left with Y over 0.1 minus Y. So we can now add in Kc as being 360 and rearrange that equation to find out Y. So once we know Y as our concentration, we now can say that was the concentration of Cl minus, so the concentration of Br minus is going to be it's going to be 0.1 minus Y of 2.77 times 10 to the minus 4 moles per decimeter cubed. Please follow the link to the website where you can download for free lots of other resources, notes for topics, video links, and exam questions and answers, which hopefully will help you in your chemistry studies.